All right, this is our video for our Chapter 2 test. So our Chapter 2 review. So I'm going to start. I went ahead and printed some of the review because there is some graphs and things. So keep in mind that this is actually from the review. This could be that Alex, the program regenerates questions every time you're in one of these assignments. So this could be, some of these could be your actual review questions. Some of them are just going to be similar. So the first one here is determining if a relation is a function. These are relations in the form of a graph. So what we're looking for here is the vertical line test. So at any point that you have points vertical of each other, so like those points are in a vertical line, so therefore they are not, that one's not a function. Then the next one, that is actually called a piecewise function. And when we're looking at piecewise functions, you're still looking at, is there ever a point where there's points in vertical? Well, this point here is vertical of, that line, which would be vertical of the point there. And then here, anywhere that those lines overlap, that's not a function. So this one was no, this one was no. Then the third one on this top part, none of these points are vertical of each other because you have here, 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 here. They're never in line with each other vertically. So this one's a yes. So now the bottom three, we have a triangle. Well, if you look just at the y-axis alone, it crosses the y-axis here and here. So there's no way that that can be a function. This one is a sideways, it's a parabola. And these lines, are vertical of each other. If you identified a point up here and here, here and here, just anywhere where those lines are in vertical, that can't be a function because those points are vertical of each other. It's not possible. So then the last one is we have this kind of squiggly line. Well, nothing would be vertical on that. So this one would be a yes. Okay? So now let's look at a question where we have, we're still determining if it's a function or not. This one's in the form of, these relations are in the form of mapping diagrams, and then these are just ordered pairs. So when we're looking at mapping diagrams, the domain maps to the range is how we word that. And you cannot map the domain, any of the domains, to two different range. So like sky just maps to 6, rock maps to 7, lake is to -3, and desk is to -3. That's fine. It's just over here, you can only have one line from every domain. So this one is a function. So the next one is a good example of when it's not a function, because this is what I was talking about. You have one line from 6, one from -3, but look right here. That's not possible. And the explanation of that is, if we had an equation that we put 7 into, and I can just quickly just give you one, x plus 3. So if I have this equation, x plus 3, and I put 7, this is my domain, so that's my input. I put 7 for that x, and I get a 10 the first time. Is there any way, because 7 plus 3 is 10, is there any way possible that if I put a 7 in there again, would I get somehow some other answer? Well, no, it's not possible. So that's why, looking at this one, it went from 7 to 8, but then it also went 7 to 3. Well, it's the same concept. You can't get 8 one time and then 3 the next. It's not possible. So it's not a function. So when we look at ordered pairs, we look at the same thing. So we're looking at our x's. You have a v, an f, a j, and a z. Well, none of those are good because none of them repeat. That means none of them are going to two different range. So this one's a function. And then the last one is you have a -8, a -8, and a -8 3 times in your x's, in your domains. You can't have that for it to be a function. So this one's not a function. Okay? So now let's look at a problem where you're given an equation, and the equation is, let's see, it was on this other page. It was 2x plus 5y equals 7. So you're given that equation, and then it wants you to check solutions. So they give you these ordered pairs, and you're going to do, if you were in the program, you would click yes or no. So the way you do that is you just, these are x's and these are y's. So you just substitute them in. And you just go one by one. And then you say, well, that's -27. That's -20. Is -27 plus -27? Nope. That one is a no. Next one. Same equation. This time you're putting a -4 where the x is, a 3 where the y is. So on this one, -20, or I'm sorry, -8 plus 15. Well, what's -8 plus 15? You would actually subtract 15 minus 8. That is 7. So this one is a yes, because those worked. The next group, 6, you're going to do 2 times 6 plus 5 times -1 equals 7. Well, that's 12. That's -5. Is 12 plus -5 7? Because it would end up subtracting, right? And that would equal 7. So that was a yes. And then the last one, you would do 2 times 7 plus 5 times 5 equals 7. So this would be 14 plus 25. Is 14 plus 25 7? Nope. So that one's a no. So that's how you would do that one. All right, moving on. We've got a problem. We're going to look at function, get into actual function notation. And this is, all this means is instead of a y, like you normally would see it like this, and that's in slope-intercept form, all they're doing is using function notation, the f of x. And so then what we do here is, this is your input, you're completing this table. This is your output, which is your y. That's the same thing as your y. So you're going to do what we would do, in any equation. If we know our x, we're going to substitute them in. And you can even use the y equals, it doesn't matter which notation you use as long as you understand what they each are. So 5 times -5 is -25 minus 3, and that would be -28. The next one, put a -4 in. So what would that be? -20 minus 3, -23. Then you've got a 1. 5 times 1 minus 3, 5 minus 3. So that would be 2. Then we've got a 2. So 5 times 2 minus 3 equals 10 minus 3, which is 7. And then the last one, y equals 5 times 3 minus 3, 15 minus 3, which is 12. So there you go. So that's completing that table for that function, given these inputs. We found our outputs. So we completed our ordered pairs. If you were going to graph this equation, you could use those ordered pairs and graph it. So that brings us to a graph. So if I'm given a graph that's already been done, and I now need to solve these functions, so they want you to find f of -2. So remember, whatever's in the parentheses is your input. That's your x. So that would be like x is -2. We are trying to find the output, which is y, which is the other half of your ordered pair. So you use your graph. Your graph is already done. So you just use your graph to complete that ordered pair. So we would go to -2 on the x-axis, and then you go up to where your graph would meet at -2. So it goes up to 2. So that means your other half of your ordered pair is 2. So that's your answer to f of -2 is 2. That's how you would answer it. The other one wants you to find the output. So it wants the 4. It wants f of x equals 4. That's your output, which that's your y of your ordered pair. We need the x of the ordered pair. So to do that, we go to the y-axis, we go to 4, and then where does that graph cross 4 at the y-axis? Well, it crosses that right at the same point. So it stays on the y-axis, which means x doesn't move. It doesn't have a value, so it's 0. So that ordered pair is 0, 4. So that means the input here is 0. And that's how you would complete those using that graph. Okay, so the next thing we're going to talk about is graphing horizontal and vertical lines. So they give you y equals 2. You're going to graph it. Well, that's a horizontal line. If it's a y equals, it's horizontal. So you would go to 2 on the, whoops, I was going on the x. You would go to 2 on the y-axis, and it's a horizontal line, and that's just simply, because what it means is if you put slope back into that equation, it means slope was 0. If I put that back in slope-intercept form, slope was 0, y-intercept was 2. So it's a horizontal line. So I'm going to go over here and I'm going to make an x equals equation. So say it's an x equals equation. Well, now it's a vertical line, because what that means is in your slope-intercept form, that meant your slope was undefined. So it makes it a vertical line. So it's a vertical line at 3, and that's x equals 3. This one's y equals 2. This one's x equals 3. Horizontal and vertical line. So now let's talk about x and y intercepts. So that's just simply what they're called. The x-intercept is where the line crosses the x-axis. The y-intercept is where the line crosses the y-axis. So this one crosses at 2. So the x-intercept, I'm going to abbreviate, is 2. The y-intercept on that graph is -4. If we need it written as an ordered pair, 2, 0 would be the x-intercept. 0, -4 would be the y-intercept, is how you would answer those if they want it in an ordered pair form. Okay, so now what if you're given just an equation and you need the x-intercept? So just like what we talked about here, if I have my x-intercept, then my y is zeroed out. If I have my y-intercept, my x is zeroed out. You're going to do the same thing if you're working these equations out. If I need my x-intercept, I'm going to zero out my y term. If I need my y-intercept, I'm going to zero out my x term using the same equation. So now this term zeroes out. So now I can solve. Divide by 6, divide by 6, x equals -3. This one, divide by -2, divide by -2, y equals 9. So my x-intercept is -3, my y-intercept is 9.